I am going to number 10, hypothesis testing. That means we have touched almost every unit. We cannot do all of them from the beginning, but I know when I touched every unit. And I selected the most important things, especially the things that can show up in a test. If you do very well in Unit 4 test, you will do very well in final exam too. Okay, so let's go to number 10 and answer some important questions there. It says, test the hypothesis using the p-value approach. Be sure to verify the requirement of the test. By the way, what is p-value again? Let's make sure. P-value is the probability of accepting the null hypothesis, p-value. Important. If p-value is greater than alpha, if p-value is greater than alpha, you accept the null hypothesis, accept HO, which is the null hypothesis, or the status quo. Otherwise, reject the null. Okay. Let's say again, if p-value is less than alpha, let me write it so that if p-value is less than alpha, you reject the null. Reject the null. All right. Okay. So that is the condition for using p-value. And this is another proportion question. So you must answer the question about conditions. Is the variance of this data greater than 10? If the variance is not greater than 10, you are not allowed to do inference. If the variance is less, you stop there. Okay. So I want to check the variance. Are the conditions satisfied? I already know that condition number 1 is satisfied because 200 is less than the population of America, less than 5%. N is less than 5% of population, of the population. So, okay, now condition number 2, is the variance greater than 10? Well, let's find out. The sample size is 200. The success is 185 divided by 200. And the failure is 1 minus 185 over 200. Because I'm using my calculator, I don't really have to simplify all this. I'm using my calculator. So I will quickly go to my calculator and put it in. But what kind of test am I doing, by the way? Look, we already told that it's a right tail test. So this is a right tail test, and I can draw a normal curve and show the rejection region. If I can be told to find the, and there, so what is the, by the way, I'm not even given, yeah, okay, see alpha. So this is a one tail test, so I do not divide alpha by 2, okay? And I will find the critical value for Z, 0.05. So I find that critical value and know when the boundary line for rejection region, okay, the boundary line for rejection region will be, I'm finding it because you might be told to find it. So inverse norm 0.05. And then the mean is the mean of a standard normal and the standard deviation. Okay, so we are not, and then we will calculate. Okay, so the normal curve is symmetrical, therefore the critical value for the right tail is 1.64. The critical value for the right tail is 1.64. Okay, so now we want to do the hypothesis test with our calculator. Trust me, don't really have time to do them by hand. But unless you're told to do it by hand, so I go to start, go to test, and I am doing hypothesis testing for P, the critical value. I mean, the conditions are satisfied. Or did we check the conditions? I think it's satisfied, but let's check it though, even because we are actually told to check it. Before I continue, let's check it. Okay, so 185 divided by 200. We are told to check it, that's why I'm trying to go back and check it. Okay, and I have 0.925. Then I can multiply that quickly by the complement, which is 1 minus 0.925. 0.925. And then because that is the Q, and I get an answer, and I multiply by N, multiply by 200. I'm checking the conditions. All right, so 13 or 14 right there. Actually, it is 13,000. So it is greater than 10, so the inference can continue. So I'll continue the inference. The conditions are satisfied. So go to stats, row to test, and I'm doing one prop z-test. Why one prop z-test? Because the conditions are satisfied. Conditions for converting from binomial to normal. So one prop z-test is number 5. And P is given to me as, of course, it wasn't given to me, but I can find it. P is not given, so let's find P quickly. Let's see. Okay, I see. I have 0.9. Sorry, 0.9 is here. Is the p-value, the status quo, and x is that, n is that, and I'm doing a right tail test, and I'm going to, I like to draw. You don't have to draw. I like to draw in hypothesis testing. Okay. Wow, that's beautiful. Okay. I want you to know that whenever the hypothesis testing, I mean, the normal curve has a lot of shading, then it means that there's a high probability of accepting the null. In fact, in this test, that's a high probability of accepting the null hypothesis. Number 5. Okay. The P, the status quo is 0.9. Okay, you know what? I have to put in because the one I put in now is the one I did before. Okay, no wonder it was too beautiful. Let's put in the actual data. Okay, and I'm doing a right tail. I'm doing it again because the data I use here are the old data. I'm using the new data right now. So sorry about that. Okay. Okay. Now I want to draw again. Okay, the shading is not, it didn't cover all of them. Still, the p-value is 11.93%. The p-value is greater than alpha. Therefore, and actually, the z-value falls into the acceptance region. The z-value falls into the acceptance region 1.78. 1.78 is somewhere here. Oh, no, 1.17. 1.178 is inside the acceptance region. That is the z-value. But they didn't ask me to use the test statistics anyway. They asked me to use the p-value. And the p-value is 11 point something percent. 11% is greater than alpha of 5%. Therefore, accept the null hypothesis. And now that I have accepted the null hypothesis, I do not have enough evidence to reject the null. The status quo is still true, it's still working. I do not have enough evidence to reject the null because I accepted the null. Therefore, I don't have enough evidence to reject the null. I want you to know that you don't have any business rejecting the alternative. You do not have any business. So you are either doing with the null or accepting or rejecting the null. So then you go to whoever employed you as a statistician and tell them, oh, look, the null still works. The status quo is still working. There is no need to reject it. Status quo is still working.